In this video, let us solve the 2-mark questions from vector algebra. Find the magnitude and direction cosines of the torque about the point of a force whose line of action passes through the origin. The point A is 2, 0, minus 1 and the origin, another point, origin is given, force whose line of action passes through the origin. Now here this A point is the about point. The force, it acts about the point and the origin will be the through point, and therefore we can calculate R vector. R vector will be is equal to the through point minus the about point, that is the origin vector with respect to the position minus OA vector. So that gives me that is 0 minus 2, which is equal to 2 I cap, 0 minus of minus plus k cap. Now, O is the origin we know. So I have taken 0, 0, 0. We have written what is R vector, and F vector is given in the equation, which is equal to 2y plus j minus k. We are asked to find the torque of the force. Torque is given by is equal to R cross F, where R cross F is equal to expanding the determinant, we get I cap into 0 minus 1 minus j into 2 minus 2, that is 0, plus k into minus 2. So that will be is equal to minus I cap minus 2 j cap minus 2 k cap. Now we are asked to find, this is the value for R cross F. According to the question, find the magnitude and direction cosine. So magnitude is equal to mod of R cross F, which is equal to modulus of minus I minus 2k. Which gives us this is equal to root of minus 1 whole square plus minus 2 the whole square, that is 4, which is equal to root of 5 units. What is the other question? We are asked the torque. So the direction cosines will be is equal to the coefficient of this R and F. So that is minus 1 divided by root 5, comma 0, comma the coefficient of k will be minus 2, therefore minus 2 divided by its modulus value, which is equal to root 5. Since we know that if this is equal to some xi plus yj plus zk and this magnitude is taken to be some r, then the direction cosine will be given as to be is equal to x by r, y by r and z by r. The next question, if A, B, C are the unit vectors such that B and C are non-parallel and A cross B cross C, vector triple product is equal to half of B cap, find the angle between A and C. So given A cross B cross C is equal to half B cap, the unit vector. So we know the vector triple product, that is A cap dot the vector which is far away from A to be taken first. So A dot C into B cap minus the vector which is closest. So that will be A cap dot B cap into C cap, which is equal to half of the unit vector B. Now compare the coefficients of B cap on both the sides. So we get A dot C is equal to half the coefficients of B cap on both the sides. Now the valuation A dot C is mod A mod C cos theta, which is equal to half. We know that A and C are unit vectors. Therefore, mod of A cap is 1, mod of C cap is 1, cos theta is equal to 1 by 2, which implies theta is equal to cos inverse of 1 by 2, which implies the angle between A and C will be is equal to pi by 3. So the distance between origin to the plane is 1, we have to show. Origin, the point it is taken to be the origin. So the given point will be taken as distance from the origin to the plane is given as mod of d divided by root of a square plus b square plus c square. So we compare the plane equation with respect to a, b and c taken as some ax plus by plus cz plus d is equal to 0. So a is equal to 3, b is equal to 6, c is equal to 2 and d is equal to 7, and therefore now the distance can be calculated. Distance is equal to mod of d is equal to 7 divided by root of a square, 3 square is 9, 6 square 36 plus 2 square, that is 4, which is equal to mod of 7 divided by root of 49. Now this is equal to mod of 7 by 7, which is equal to 1 unit. It is what asked in the question. Show that the distance is 1 unit. Next question, show that the given three vectors are coplanar. We take the given vectors to be A vector, B vector, C vector. We have seen a property, the vectors are coplanar. Thus, when the box product, if and only if the box product is 0, scalar triple product is 0. So A vector, B vector, C vector are given. We find the box product of A vector, B vector, C vector, which is equal to determinant of 2 minus 1, 3, 1, minus 1, 0, 3, minus 1, 6. Expanding the determinant, this is equal to 2 times of minus 6 minus 0 minus of minus 1, that is equal to plus 1 into 6 minus 0 plus 3 into minus 1 plus 3, which gives us this is equal to minus 12 plus 6. This is plus 2 into 3, again plus 6, which is equal to 0. So box product is 0, which implies A vector, B vector, C vector are coplanar. Find the vector equation of a plane which is at a distance of 7 units from the origin having the direction ratios of a normal to it. Therefore, given P is the distance at a 7 unit, direction ratios are given, direction ratios of a normal. So, n vector will be is equal to 3i minus 4j plus 5k. Let us find what is the n cap here. N cap will be is equal to n vector by mod of n vector, which is equal to 3i minus 4j plus 5k divided by its modulus, that is root of 3 square plus minus 4 whole square plus 5 square, that is equal to 25. Now n cap is equal to p, that is r vector dot 3i minus 4j plus 5k divided by its modulus value will be root of, this is root of 50, which is equal to the distance 7. Now this is r vector dot 3i minus 4j plus 5k divided by root of 50 is 5 root 2 is equal to 7, or in other words it can be written as r vector dot 3i minus 4j plus 5k is equal to 35 root 2. If Cartesian equation is needed, just replace I, j, k by x, y and z and we get the Cartesian equation, which is 3x minus 4y plus 5z is equal to 35 root 2. Find the distance of the point to the plane, given plane. Point is given, plane is given. We are asked to find the distance of the point to the plane. So distance calculated by capital D. Given point vector equation is given. We'll write the Cartesian equation, that is the easiest form to find the distance. Cartesian equation, replace ijk by xyz, so minus 3y plus 2z is equal to 5, bring it to the left, so minus 5 is equal to 0. Now the equation is of the form sum ax plus by plus cz plus d is equal to 0, where a is equal to 6, b is equal to minus 3, c is equal to 2 and d is equal to 5 here. We write distance of the point from the plane is given. Now the point here will be taken as some x1, y1 and z1 is the given point. Now replace all these values. So d is equal to, from the plane equation we take what is a, that is 6, x1 point is 2 plus b is minus 3 into y1, that is 5 plus c is 2 into z1, that is minus 3 plus d, that is minus 5 divided by root of squared 6 square 36 plus 3 square 9 plus 2 square, that is 4. Now this gives us, this is equal to mod of 12 minus 15 minus 6 minus 5 divided by root of 49, which gives us this is equal to 12 minus 15 minus 3 minus 3 minus 6 minus 9 minus 9 minus 5 is minus 14 divided by 7, which is equal to mod of minus 2, which gives us the distance will be is equal to 2 units. The next question, A, B, C are the three vectors, then prove that this box product is equal to box product of A vector, B vector, C vector. For this we use the theorem what we have learned, that is theorem 6.6 from the textbook. If A, B, C are the three vectors and P, Q, R are any two system of three vectors, and if P vector is given, Q vector given, and R vector given, then the box product of P vector, Q vector, R vector can be represented as determinant of the components of P vector, components of Q vector, components of R vector into the box product A vector, B vector, C vector, and we are going to use this to solve the problem here. So we'll take the LHS first. That is, this is equal to determinant of the coefficient of A and C are 1 here. There is no B, we give 0. So 1, 0, 1, 1, 1, 0, 1, 1, 1 into the box product of A vector, B vector, C vector. Now this is equal to expanding the determinant. The value of the determinant is 1. So we get 1 into A vector, B vector and C vector, which is equal to the RHS.